Now let's see example, so numerical 7.7, exercise question 7.7 of the chapter number of 7. A charge 30 microfarad capacitor is connected to 27 millihenry inductor. Means the capacitance is 30 into 10 raised to minus 6 farad. Inductor is, it's 27 millihenry. Inductance is L, that is 27 into 10 raised to minus 3. Okay. What is the angular frequency of free oscillation of the circuit? Means see, when the word is free oscillation, we can consider it as a resonance condition. Okay, so in that case, the angular frequency omega 0 will be equal to 1 upon root LC. So this will be equal to 1 by root inductance, that is 27 into 10 raised to minus 3, and capacitance, that is 30 into 10 raised to minus 6. So this will be equal to under root of 27 to 30, it's 810 into 10 raised to minus 9. So for square root, we must rearrange it. 81 into 10 raised to minus 10. So square root of 81, 1 by 9, and square root of 10 raised to minus 10 will be 10 raised to minus 5. Okay, clear? So now taking the square root, it's minus 8, it's 81 into 10 raised to minus 8, minus 9 plus 1. So this will be equal to minus 4. Okay, so 1 divided by 9, that will be equal to 0.111 into 10 raised to plus 4. So the angular frequency will be 1.1 into 10 raised to 3. Clear? So this will be the angular frequency, or else I can also write it down like it will be 0.1111 into 10 raised to 4. So 1 radian per second, round figure. Okay, this is the value of resonant angular frequency. Okay, so this was about 7.7. First note it down, then we will say 7.8. Now let's see question 7.8. Now question 7.8. Suppose the initial charge on the capacitor in question 7.7 is 6 millicoulomb. Means the charge is equal to 6 into 10 raised to minus 3 coulomb. What is the total energy stored in the circuit initially, and what is the total energy later time? We should first find out what is the total energy stored initially. Okay, so initially the charge was Q. So initially the energy is in the form of electric field stored in capacitor. So that will be equal to Q square by 2C. So 6 into 10 raised to minus 3 whole square upon 2, and capacitance, that is 30 into 10 raised to minus 6. Okay, so 6 square 36 into 10 raised to minus 6 upon 30 into 60 into 10 raised to minus 6. This will get cancel. It's 36 by 60. So that will be equal to 0.6. Okay, 0.6. 6. So we will get 6, 6 or 6 10. So 0.6 joules. So the initial energy will be 0.6 joule. Now the question is, what is the total energy? Now, so initially the energy is only stored in the form of capacitor, and then because the current inductor is 0, and the charge in the capacitor is maximum charge. Okay, so initially the total energy will be equal to the initial energy. So the total energy will be equal to initial energy, and that will be 0.6 joule. Clear? So this was about question 7.8. So note it down. Now, let's say example 7.9. Not example, question of exercise. Question number 7.9 of the exercise. A series LCR circuit with resistance 20 ohm, inductance 1.5 Henry, capacitance 35 microfarad. To a variable frequency 200 volt AC supply. So I can take this as VRMS. Okay. When the frequency of the supply equals the natural frequency, what does this mean? When frequency equals the natural frequency, this is the condition called as resonance of the circuit. What is the average power transformed in the circuit in one complete cycle? Now we know that the formula for power is V square by R. In fact, here it will be V RMS square by Z, where Z is the impedance. But now it is clearly given that resonance condition, the frequency matches the natural frequency. So what happens to resonance frequency? Capacitive reactance and capacitive reactance, that is XC and XL, inductive reactance, the value of both are same, right? So the only component responsible for impedance is the resistor. So here I will write down R at resonant frequency. Z is equal to R, because XL and XC both are same, so XL minus XC square, that will be equal to 0. So now VRMS, that is given to 200 square, and resistance, that is 20. Okay, so it's 200 square upon 20, that will be equal to, so 2000 watt. Here, so this is the power. Okay, so this was about question 7.9. Note it down.